this video I'm going to show just two examples of something called the difference quotient. So the difference quotient is basically the slope of a little segment of a line. Okay, so if we take and we have an initial point at some point x. Okay, there's our initial point, and so the y value here, that would be the output for whatever our function is. You know, we input x and the output is the y, all right? So then if we go over a certain amount, some, let's say h, some distance, this new point is x plus h, okay? So when we go up and look, where does that hit on the line? That new y value is the output when we put in x plus h. Okay, so now if we wanted to find the slope of this line, just this little section right in here, the slope is the rise over run. Okay, so we would take the difference in the y's. So our first, you know, we would take this, there's a y value. There's the y value, okay, and then we subtract the first y value, which is f of x. And then we take the difference in x's. So where did we get to for x? That's right here, minus where we started, right there. So this, all of this is just a really complicated slope equation. And it can be simplified just a tiny bit because down in the denominator we have an x minus an x. Those add up to 0. So you end up just with an h down in the denominator. This is our difference quotient. And it's going to be useful for us to get a sense of what is the average slope of a line in, you know, this little segment. In calculus, what we're going to do is just make h smaller and smaller and smaller so that we can find the slope closer and closer and closer to just one point. Our goal in calculus is to try and figure out slope when you only have 1 point. That seems impossible because slope you need 2 points, but that's the goal in calculus. Okay, and the difference quotient is a really useful tool for that. So let's look at an example. All right, here's our function. F of x is equal to 5x minus 2. So the difference quotient, what we do is we would take the f of x plus h, and then minus, this is a really important part, a lot of people make a mistake on that one, minus just plain f of x, all right, and then that's just all over h. Be really careful of that minus. Okay, so here we go. F of x plus h. Okay, I'm just going to copy my function 5x minus 2, but instead of x I put in x plus h. Okay. Now I have to be really careful, make sure that you're subtracting f of x. So subtract 5x minus 2, that is f of x right in here. And you have to subtract the entire f of x, so that whole 5x minus 2 needs to get subtracted. So that needs to get put into parentheses, and then we'll actually end up needing to distribute that negative. Okay, so let's see what ends up happening here. We'll distribute our 5, so we'd get 5x. Oops, ooh, I forgot. Difference quotient needs to have an h in the denominator. Okay, so now we would have 5x plus 5h. Oh, this is a little messy. I'm going to scoot this down a little bit. Okay, so we'll have 5x plus 5h minus 2 minus, distribute that negative, so it would be minus 5x and then plus 2. You distribute your negative to both of those. And I always forget the denominator. Make sure that we keep track of that. Is still all over h. And then these usually clean up really nicely. We've got, let's see, 5x subtracts out with those 5x, the negative 5x, and then our 2's also add up to 0. So we just end up with 5h over h, which is 5. And if we go and look at this equation for this line, the slope there is 5. And the difference quotient is a slope. That's the slope of the line, okay, over any segment. And a straight line, there's down to up 1, 2, 3, 4, 5. A straight line, it doesn't matter where you go, like if this is X and this is H. This little segment that I'm looking at, that slope is going to be the same if I just look at a small segment, because the slope on a line between any points is always the same. That's what makes it a line. Okay, so it's not surprising that the difference quotient is the slope. But it doesn't work that way when we have the difference quotient of a curved line. So let's look at this quadratic. Okay, the difference quotient is going to be f of x plus h minus f of x all over h. And this is the part we really want to try not to mess up on, where we're subtracting f of x. Okay, so f of x, let's see, f function is x squared minus 3x plus 8, and instead of x, I'm going to put in x plus h. So here's difference quotient. And then make sure that I subtract my f of x. So f of x is x squared minus 3x plus 8. And that is all over h. And it's going to get a little long here. So here we go. We've got x plus h times itself. So quantity squared. And then I'll distribute my 3. So minus 3x minus 3h plus 8. And then I'm going to distribute that negative. So minus x squared plus 3x and then minus 8 all over h. I'm going to distribute my x here, so I've got x squared plus an xh plus another xh, so plus 2xh, and then plus h squared minus 3x minus 3h plus 8 minus x squared plus 3x minus 8 all over h. And then we see what we can simplify. My x squareds add up to 0 there. My 3x's and also my 8's. Okay, so then I would get 2xh plus h squared minus 3h all over h. And then we can factor out, each of these has an h, so I'm going to factor an h out. So I've got 2x plus h minus 3, oh, that's red, all over h. And then my h's can cancel, so the difference quotient here is 2x plus h minus 3. And that would be the slope of the secant line given a specific little section. And that does represent x, or that does represent slope for the secant line in this section. It's just that the slope isn't the same because it's a curved line. Okay, so it really depends what your x value is, and then how far across, how big your h is. That will affect that slope of the secant. Okay, so if you knew those, you could plug them into this little expression and you could get the slope of this, very specific little spot for the secant. So the goal right now in this class is for you just to be able to do all of this algebra, and so that then when you're being asked to use it again in calculus, you'll have the algebra tools that you need. Okay, so the big part that people can make a mistake on is when you're subtracting f of x, so just be careful on that section. And that is difference quotient.